Hi, folks. So today we'd like to explore a bit more on the concept of abstraction. Just think about it further. So if I were to say that abstraction is just the capability to name things, would you agree to that or not? So let's say if that is what it is. Abstraction is basically the capability to name things, right? And let's say name things. All right. So this could be, let's say, in maths, in software, it could be in, let's say, in terms of naming concepts. It could be in terms of language constructs, right? But underlying, it's essentially the same mental faculty that we are using. A very essential mental faculty that is very much a part of our human identity, a unique part. So let's say, what would it look like in terms of mathematics, right? So let's say you have functions. So function is essentially, it can be thought of as a name, right? So let's say there is a single variable polynomial, let's say x squared plus 2x plus 1, or 3 variable something like 9z cubed plus whatever 8y square plus 100x plus 7, let's say, right? So what is this? This is something that is describing the behavior of a function, and this is the name, right? So similarly, in this 3 variable function, this is the detailed behavior of the function, which captures the details. And this is the name that I have given to that behavior. And this name is very convenient because, as you would remember, this name enables us to forget the details, that is the detailed behavior, and just refer to it by name. Because, so, let's say elsewhere in that page, if I write g of x of y of z, let's say, I don't need to refer to all of these details again and again. So what is it really, a mathematical function? It's just a name. And yet I have used the power of abstraction, to abstract out the name from the details, to articulate a mathematical thought, a mathematical pattern, something which can be useful, right? Similarly, in terms of software, let's say, again, we have functions in software, as we alluded to, or did not allude to, mention in detail. We could have a square root function operating on an integer, and, any other class, let's say some complex class does something class, right? Whose constructor, let's say, takes an input of an integer and a string, the constructor of this class. So what really is this? The square root. This is a name. That's all about it. Its implementation hides the detailed behavior behind that name. Similarly, this does something class. What is it really? It's just a name of a class. And the behavior of that class is hidden behind uh, the pattern, the constructs, other constructs, the behavior um, behind that name, right? It's member functions, member variables, so on and so forth, constructors, destructors, so on and so forth. But what really is this? It's just a name. And this, the capacity to name it independent of its detailed behavior and pattern, that is what is abstraction, right? So I thought a couple of uh, what do we say? These examples could shed some more light, some clarity, some discussion. So another thing is very interesting in terms of concepts. So this is where it gets a little bit, just a tiny little bit tricky. So let's say think about concepts. A concept could be anything. Let's say the concept of sound, right? Or the concept of let's say a detailed process. Let's say human digestion, right? The concept of digestion. Or let's say the concept of texture. You know, what does it mean to feel a texture, right? So again, these abstractions. So when I say sound is a name, right? Which is I have named uh, to sort of attempt to define or get a handle on whatever it is that I want to discuss about sound. Its physics attributes, you know, its melodious attributes, its tones and whatnot. But it does give me a handle because it tells me of my intent, right? What is really my intent? I have to discuss something about sound. So I have to name it in such a way that I can get a handle on it and then hide some of the complexity, the detailed discussion, the patterns, and so on and so forth, the angles and the depths and correlations and discussions and everything, the details, hide it behind that name. That name is called sound. So let's say in terms of human digestive system, it's the same thing, right? Um, so I'm not a biology student or a doctor, but I do know that human digestive system is fairly complex, right? It has, who knows, dozens and dozens of sub processes and complex chemistry and whatnot. But in order to discuss it, in order to explore it further, in order to communicate it with anybody, communicate about it with anybody, right? I do need to have a name. And that is an abstracted out name. That name is called digestion or digestive system. Um, and that is also an act of abstract thinking, right? So as you can see, when we are discussing concepts for whatever intent, we do deal in abstract thinking, and the concept of abstraction is set into motion, right? And just as we discussed in terms for sound, we could say that texture is also a name to get a handle on a phenomena, which is to feel some physical properties of materials through the sense of touch. And once we get a handle on it, that this is what we mean by a name for naming a concept called texture, by abstracting it out, now we can discuss it further, explore it, research it, talk about it, whatnot. All right. So similarly, natural language constructs, like let's say if we were to make a table representing tiers, multiple tiers of human language constructs. So let's say if we were to take English, uh, it is our basic alphabet, A, B, so on till Z. So what are they? There are 26 alphabets, right? Total 26 of them. So A is a name, B is a name, Z is a name. It is a name because it gives us a handle. When I say A, I mean exactly A. Nothing more, nothing less. So A is a name. It's an abstraction, abstracted out to be used further for further utility, right? It remains an abstraction nevertheless. But as we see, human language is, any natural language is very complex. And so after alphabet, let's say, what do we make? We join alphabet together, we make words. So words represent something, words are complex. There's an entire grammar and the notion of what is it that words represent. That's a discussion for another day, but nevertheless, words like the, zoo, etc., are combinations of other abstractions from alphabet to make a higher degree of abstraction called a word, which has some meaning attached to it. How exactly? Let's leave that discussion to another day. For the purpose and scope of this video, it suffices to leave it here, right? So afterwards, what do we have next? So we have sentences. So as we move on to higher tiers, sentences are made of words, so on and so forth. So, we have paragraphs and whatnot, uh, novels and poems and stuff. So an alphabet uh, at a tier. It is an abstraction. So is word. So are sentences. So are paragraphs. So are higher uh, higher degrees of human language constructs, human language artifacts like novels and dramas and poetry, etc., etc. So English, as it happens to be, uh, now much of this delves into linguistics, of which I'm just a novice and a layman enthusiast. But let me share and discuss what I wanted to in this context. So A has a sound attached to it, B has a sound attached to it, so on and so forth. Um, and A is an abstraction, so is B, so is each one of those. So, but there are some other languages in which the sounds are not as basic as they are in um, the class of languages called. Let's forget what it's called. Let's say languages like English. Like for example, as opposed to English, the Chinese alphabet has a different feel to it altogether because it's much larger and its correlation with sounds is not uh, of the type that it is in English, for example. And yet, this again is also abstraction and action. What to abstract, what to leave to details, which tier to abstract a certain thing to, where to leave the rest of the details behind a name, where to move on to the next tier to use the earlier tiers names, abstractions, and build complex things from it. These are all decisions of abstraction, basically, right? So, let's say if there were a hypothetical alphabet where, there was some guy or some human beings who could only, write pictorial things, right? So let's say they've had this kind of a symbol for a tree, let's say, and let's say a crude drawing of a cat. So let's say you get the idea. So let's say they had this kind of a symbol set for uh, that they that they associated with the concept of alphabet at tier of alphabet level, right? So they would speak it who knows what. But let's say for the sake of this discussion that against this symbol they had a way to put it to sound, against this symbol they had a way to put it to sound. And who knows, they had 1,000 of these symbols, like something like Egyptian hieroglyphics or something. The point I'm trying um, to put forth is that the decision of abstracting out a complexity layer at this tier, which is, let's say, tier 1 of the language construct, and using it in tier 2, um, so let's say this is tier 2, this is tier 3, this is tier 4, so on. So this choice of tier 2 being definable in multiple ways, in somewhat English style alphabet, or somewhat of a Chinese style alphabet, or somewhat of this hypothetical style alphabet in tier 1. My point is that at this tier, we could choose to define the abstractions differently, of course, with implications, right? So that basically is the power of abstraction. It lies everywhere that we see human imagination at work, human ingenuity at work, human engineering at work, human creativity at work, like so it basically lies everywhere. So thank you for listening to this, and I hope this was somewhat useful. Have a good day. Bye.